Hello, everybody. Good morning, good afternoon, good evening. It depends on from where you are joining the program. Welcome to Big Bang Data Science Solution Ramadan program, the Data Science for Good. And welcome to week 2, session 1. So in week 1, session 1, we simply talked about data explosion. Yeah, we talked about data explosion. We talked about the importance of why we need to learn data science. We talked about analytical types. We talked about data science career. We talked about portfolio and data science is data science activity, day-to-day activities. So then in the session number 2, which was on Sunday last week, Ed did crash course in Python. I believe he talked about lists, different lists and dictionaries, sets, tuple, probability functions, and some of the conditions. So this is a basic crash course on Python, which is going to be the programming language which we are going to use throughout this mini program. Today we are going to learn some basics, some basic thing that you always need to start with when it comes to data science, when it comes to starting your machine learning project. And today we are going to talk about business understanding and CRISP-DM. CRISP-DM is a methodology that we are going to use. For information, I have more than probably 56 participants. They have not accepted the invite yet. Please go ahead, accept the invite. If you were to access the recording and also if you were to access the training materials. If you don't want to join the Canvas, that'll be great. No, that's fine. But please go ahead and follow me on YouTube. So this is my YouTube channel. Please go ahead and subscribe. If you are an Arabic speaker, you don't know, you don't understand English. I have a lot of videos in Arabic. And also start posting the recording, through my YouTube channel. So please go ahead and subscribe to it and follow me. And yes, I will keep posting a lot of videos throughout the year. So that is the plan for those who don't want to join the Canvas or they are having problems joining the Canvas. You always have a plan B, and that is to follow me on my YouTube channel and just go through the recording. If you have, of course, a question or concern, you could ask a question in my YouTube channel. Also, if you need an assistant, so please go ahead and simply schedule a one-to-one session with me, and I'm going to share the link on the chat, and I will be more than happy to address any concern, any doubt, any problem you're struggling with. So that is all I can do to guys help you. Even though it's a free program, I still can help you. We still can help you. Okay, so so this is me. For those who just joined, my name is Muhammad Midwani, but I go by Muhammad Midwani. This is my email address, mo.midwani@bbds.ma. This is my phone number, and this is my LinkedIn. Yeah, always good to connect. I'm going to share this with you guys. Connect with me. You never know. Building a network is always good. Always your benefit. You never know. So that is just me. And I'm doing my PhD in artificial intelligence. I'm doing my PhD in artificial intelligence. I have 4 master's degrees. Master in machine learning, data science, information technology, and MBA. And I'm looking into my 5th master's. I love to be in school. I have 20 years of IT experience, almost 8 years of 9 years now, probably 10 years now of data science and analytics. And I am the founder of Big Bang Data Science Solutions, which is the company that offers you guys the free program. So this is a recap. In the last week we talked about the explosion of data. This is some facts about the amount of data generated by most of the companies across the globe in the 24 per minute. So all these numbers, they are per minute. This is a huge amount of data being generated every 24 hours. And as a matter of fact, we don't have enough trained, skilled people like you who can take this data, any data, and try to find some patterns, some insight that could help the management make a better decisions. Okay, we talked about data science. We talked about we talked about the concept of data science. What is data science in general? The disciplines in data science in general. We talked about that. We talked about the ultimate plan. Someone might need to mute Hari Sharma. Please mute yourself, otherwise I'm going to kick you out. Hari, one, I'm going to kick you out, unfortunately. Bye bye. So that is the rule. If you don't want to mute yourself, we are going to kick you out. So these are the ultimate plan. If you want to be to be a superhero data scientist, you are going to need some domain expertise in your field. If you are working on healthcare, please go ahead and add analytics to it. Don't learn data science from scratch. It's going to be a waste of your time, waste of energy, and of course you might not get paid the amount of the your current salary. And you need to learn some programming languages, either Python or R. You need to know some mathematics, probability to help you make sense of your data. You don't have to be an expert, of course, but you need to know little to help you understand the position of your data, the dispersion of your data, the shape of your data, the relationship of your data, the distribution of your data. And of course, you need to start learning the foundation and the lingo. In the program I'm teaching, we are building we are building that lingo. I'm going to share with you some of the slides we covered throughout the program. So for example, in week number so we got so far we got in week number 14, and we keep track on the big words. So these are the words that we learned in week number 2, then words in week number 3, words or terminologies in week number 4. So all the way to now we are in week number 15, and these are the words that we learned in cluster analysis, anomaly detection. These are the big words that we learned in week number 14. So these words are exactly what you are going to need in in the ultimate plan. So you need to speak, to start speaking the data science terminology. If I were to ask you, for example, on what is decision tree, you should have a straight answer, an answer in there. Right. No, here we go. Entropy, that data split, modeling, training, set, etc. And the reason why we are building the lingo and foundations, especially for my program, simply for two reasons. Number one, to help you ice your interview for the first time, the first shot, and number two, we are preparing our students for the certified analytics professional certificate. Yeah, we are preparing.
Assalamu alaikum, Dr. Medwani. I can only see your picture. I didn't see the slide you're talking about. Which you're gonna show.
Yeah.
I'm only looking at your picture.
Yeah, this I'm gonna load these slides towards the end of the day. Yeah, we are gonna see them in week number 2. Okay.
Okay, thank you.
Thank you. So the lingo, this is a part. This program here is free, provided for students taking the master's program, and this program itself is $1,100, but you are gonna get it free of charge. And that is what we are doing here with this lingo, is simply helping students, preparing students from day one for their big day, which is the interview day, and also preparing them for the CAP certificate. And finally, You have to work on some projects. So that is the plan. Okay, so now let's assume that you are a data scientist. You've been hired as data scientist, and you'll be working on some cases or some problems. So these are some problems that you will be working on, and one of them, the one that we will talk about the program, it's not our insurance. It is going to be bank churning problem. So, but let's take a look into a typical problem. So you are working with an our insurance, and the manager calls you in, and he, after of course introduce you to the organization and everybody in the team, he told you, Mr. X, in spite of having a fraud investigation team that investigates up to 30% of all claims made, we are still losing too much money due to the fraudulent. So this is it's called statement problem. This is the problem that management are willing to hire you and invest a lot in you, bring you in to be able to help them fix it. The business are losing a lot of money because of fraudulent, and they hired you as an experienced data scientist with the hope that you could design an automated solution for them using machine learning to fight this fraudulent. So that is the plan. So this is simply a basic problem, and the same applies to any problems across industries. So you could be working in a bank for trying to fight the fraudulent transactions. You could be working on a charity. You could be working in any domain, regardless of the industry. And your job is to analyze their data and fix their problem. So again, if you were to start, and I ask this question multiple times. I ask my students multiple times. If you were to start, if you were that lucky data scientist that been hired, just been hired, and you had this problem here, how do you start? And trust me, most 90% of the my students or the participant on any program that I share this with, they got the answer wrong. They some of them they say we could start with getting the data. Some of them would say that we would start by looking into the 70%. But according to Albert Einstein, is said if I was given 1 hour to save the planet, I would spend 59 minutes solving the problem, and 1 minute resolving the problem. So the best approach to any problem that you'll be working on as a data scientist is to be able to spend more time to simply define the problem. Before you think about the solution, before you think about the data, before you think about the automating thing, before you think about the requirement, just sit down a little bit and take a time and think about the problem itself. What is exactly the problem that the management are facing? And trust me, guys, more than 80% of analytical project, they fail simply because someone was not someone was not clear about the starting, and they were not prepared for the ending. Starting means either probably you misunderstood the problem, you misunderstood the requirement, you misframed the problem, or you misunderstood the data used for the problem. If you misunderstood the problem, of course, there is no way you can design a solution of non-biased, unbiased solution. And the end, because you were not prepared for the end, you don't know what are the objectives. If you don't know the objectives, of course, you are not going to design a solution. If you know ahead of time that the solution that you are about to design for this industry, if you know that the solution will be implemented in production, of course we are gonna prepare for that from the early stage of the project. Otherwise, it is going to be so hard to explain what you did to a developer and expecting them to implement your solution into their production successfully. So 80% according to expert of the analytical project failed because of these one of these two reasons. Okay, so yes, this is the philosophy you should be you should apply to all problems, not only analytical problem in our life. So if you have a problem, before you're thinking about the solution, just try to understand the problem first. Try to you know fill apart this problem into small, manageable, quantifiable, analytical pieces before you start thinking about the solution. So this is the typical workflow. Now this is your flow for the framework or the flow of any analytical machine learning project. So you start with the problem. You start with the problem first. Analyze. Understanding the problem, the way the management understand it. Then of course we need to frame it. We need to apply some business domain knowledge. Then you need to extract some mapping in there. Then once everything is green, then we are going to move into data. We are going to get the data by simply we gather data. There are a lot of pre-processing, feature selections, etc. Then we build the models, we test the models, and finally we implement the solution into production. It's a simply a simple workflow, but we are going to go through this with much more detail, step by step. But analyzing and conducting analytical machine learning project is managed through a flow. It's not something that you could do within a click. It's time consuming. So when you are dealing with a problem like this, the first thing that you need to think about as a data scientist is think about it from the macro strategy and micro. And I will explain them. The micro, sorry, there is a spell there. Micro, yes. So think about it from the micro strategy and strategies and macro strategies. So for to monitor the progress of your project from the start to the end, there are two type of methodologies that you need to implement: the micro methodologies and micro methodologies. Of course, micro methodology is simply a method, simply a scientific method that you could use to help you monitor the progress, the flow of your movement, of your progress, of the machine learning. It depends on the organization you are working for. Some organizations, they already have some methods being implemented. Scientific research method if you are working on a research field. So this is probably the best, the optimal methodology you could use. You start with a question like how we determine, talking about linking this to the problem we are trying to solve. How do we determine a claim as a fraudulent or a legitimate? That is probably a question. Then then we state the hypothesis, examine, refine the hypothesis, investigate, collect data, get the analytics. So there is one way, and this is only works for research field, then operations fields, and waterfall. This is another one. But the most common one that I used in the most common one that I used in the analytical in analytics in general, it's called CRISP-DM. And there are others, SAS for Enterprise Miner, SAS company, SAS, they have their own methodologies called SEMA. SEMA, sample, explore, modify, model, modify, assess. So that is the methodology for the SAS. So, but the most common methodology that you'll end up using for your entire project is called CRISP-DM, and CRISP-DM stands for Cross Industry Standard Processing for Data Mining. And this CRISP-DM is phased. It has 1, 2, 3, 4, 5, and 6 phases, actually 7 phases. So you first start with understanding the problem, understanding the business you are working for, understanding the business problem you've been hired to fix. Then once you get that cleared, you acquire the data. Then you spend time analyzing, investigating your data, understanding your data, using some of the probability techniques, statistical techniques that we learned, that we talked about. Then once you have a clear understanding of your data, of course, the data would come with a lot of data quality problems, a lot of errors, a lot of typos, a lot of discrepancies, a lot of missing values, outliers, duplicate records. And this data is not ready yet for analysis. So we need to prepare it. We need to prepare it and pre-process it. So once we have a clear, ready to go version of the data, then we are going to start modeling. We are going to start applying some machine learning, and we are going to learn this through this short mini program. So we are going to build as many models as possible, and we are going to evaluate them. We are going to evaluate all these models, and we are going to pick one model, one algorithm that with the highest accuracy, which yields the highest performance, and then we are going to deploy that into production. So this is the micro methodology that most likely you will be using if you were to work on analytical project. If you work on other projects, probably CRISP-D might not be your option. You might use some method or research method or warfare method. Yeah, Abid, please get in there. Otherwise, I'm going to kick you out of the room. Abid, Abid, thank you, sir. Okay, so that is for the micro methodology. So once you determine the micro methodology, then within this micro methodology, you need to determine the micro methodology. So micro methodology is simply, what exactly are you trying to do? So let's say that with the problem that we want to solve, this problem here. So we already determined that we'll be doing CRISP-DM, which is the most common methodology used in analytics. And now, what are we exactly trying to do? Are we trying to do some descriptive analytics, simply trying to find answers to questions about something happened in the past? Or are we trying to do diagnostic analytics, simply trying to find answers to questions in terms of why something happened in the past, why? Or predictive analytics, simply trying to answer questions in the format of what is the probability, what is the likelihood something is going to happen in the future? Or are we trying to do prescriptive analytics by simply trying to answer questions in the format of what is the optimal option, the optimal method, optimal way of doing a business? So that is what we need to determine. After we agreed on the micro methodology, we need to determine the micro. If we were to do descriptive, are we simply trying to explore the data, try to explore, discover some patterns, some relationships, some signals, some correlation? Or are we trying to build some prediction where the data is required? Or are we trying to build some prediction where the data is not required? That is some of the decisions that you need to take, you need to make at the early beginning of your project. So in terms of micro methodology, if you were to do the exploration and discovery, you really don't need to machine learning. You don't need to apply some machine learning. You could use simply some statistics. You could use basic statistics like ANOVA, MANOVA, linear programming, hypothesis testing. It's simply statistics. Now, sometimes, yes, you might need to apply some machine learning, especially if you are using class tree analysis or where if you are doing the unsupervised learning. Unsupervised learning does not require prediction, so you still could use statistics, and you could use machine learning. If you were to build a solution, prediction solution using the data, of course, there are a lot of directions. You could use a general linear model, factor analysis, clustering, regression, classification, time series, etc. And sometimes you might not have a data, so you might need to build a model to simulate the problem, simulate the data. So this is out of the scope of this program. So mathematical programming, mathematical optimization, linear programming, non-linear programming. This list of animals here don't require data to build a solution. Okay, so as a data scientist, you are going to need four things. You are going to need four things to build a solution. You are going to need the data. And the data, again, is going to be in the format that, in the ready-to-go format, not the raw data. When you first started, you could get a raw data, which could have a lot of information, a lot of problems. So once you bring the data to meet certain assumptions, then that is the data we are going to need for the modeling. And of course, we already know the type of the model we are going to use. So this is the macro. We already know our macro strategies. We know that we'll be doing discovery, exploration, or prediction. We know it. And we know the end result. We know what we're trying to achieve. We know we're trying to find answers to something that happened in the past, like when, where, what. Or we're trying to find answer to what is the probability, what is the likelihood. The only thing that is missing out of this equation is the hidden variables, or it's called parameters. And this is something that we are going to find. This is what we are trying to, this is the model. This is why we're trying to extract or learn from the data. Once we learn these hidden variables or these hidden parameters or these patterns or this relationship, we can apply it on unknown, unseen data. So this is another mental picture that I would recommend that you guys remember or memorize or understand. So as data scientists, if you were to build, if you are working on a solution, these are the building blocks or the ingredient of your system. You are going to need the data clean, ready to go. You are going to need to determine the models that you'll be using. You are going to need to determine the objectives. And of course, you are going to use the model and the data to find the patterns that we are going to use as an inference for any unknown, unseen data or future data. Okay, I'm going to stop here for a second and let me see if you guys have any question, any concern, any doubt. Now you can unmute yourself. Please unmute yourself and ask your questions. Please ask questions, you guys. You don't have to be shy.
I've got a question.
Yes, sir. Paul, go ahead.
Yeah. Oh, shoot. Well, I'll wait. I got two.
Paul, your audio is not clean. It is not clear. Paul, is there a way you can fix your audio, please?
Brother Mo.
Yes, say it.
This is my first class. I missed previous classes. Are there any important which I miss, which I will not understand in this class?
Probably, yeah. So just stay, don't leave, and you might need to go through the recording from last week.
Okay, thank you.
Okay. You're welcome. Okay, I'm going to take your silence as no question, and let's proceed. Yes, Paul, you have a question?
This course is preparing
Yeah,
us for the certificate program.
certificate program. You're talking about the 30-week program, right?
Yeah.
So what do you want to know about it?
Okay, it's kind of taking this course is going to prepare us for the
Uh,
take the certificate.
no, this is. I mean, this program here is a mini program. Of course, you are gonna for sure benefit from it, but I don't think it's gonna take you anywhere unless you invest more time wise, effort wise, and money wise. So data science is a journey. There is no course out there. There is no program out there that would make you a superhero data scientist. You have to make yourself that superhero data scientist, but put in a lot of investment. Yeah, this program will guide you, will open doors for you,
Mhm.
will show you the importance of learning data science and importance of data science in general. But it's totally up to you on how to approach it. Completing the
Yeah, three
program,
years.
yeah, completing this
3 years
program
is my approach.
yeah, completing this program will definitely open so many doors for you in terms of upscaling with data science. Okay, but if you want the certificate, you want to, probably you might need to take our 30-week program, and that program will be offered in August 1st or 2nd of this year. Okay, Paul.
Yes.
Hey Mo, I have a quick question.
Yes, sir.
Is it possible that you can share the slide as well or
The slides
something?
will be
Because just to no. While we are talking, just to comprehend a little bit better.
unfortunately they have to be through the canvas.
Okay, Canvas.
That
Okay,
is
so
that is a business rule. Unfortunately, everything will be accessed through the canvas.
okay, thank you.
Okay, my apologies. So as I said, there are a lot of methodologies that you could utilize or you could use for to monitor the progress of your project. And the most common one is the CRISP-DM, which we talked about a while ago. And CRISP-DM stands for Cross Industry Standard Processing for Data Mining. And I believe there is if you were to Google it, there is a PDF file.
Yeah. So just to answer the previous question, we are able to see the slides. Brother Mo is sharing. I think if you log in through your computer, your PC, you're able to see that. But if you're logging in through your mobile phone, then you're not able to see what is sharing.
Thank you. Yeah, thank you for sharing that.
I logged on from my Mac and I couldn't see the slides for a while, but then I signed off and joined again, and now I can see the slides. Just to inform you guys.
Yeah, but I'm sharing my slides. If you don't see my screen, then probably you might have a technical problem. But anyway, when you look into the CRISP-DM, I think there is a nice PDF file available. I have a version of it. Yeah, so this one. I'm going to share this with you guys on the on the chat. So please go ahead, take a look. Always you are going to learn from it. So this is a document for this CRISP-DM, how to implement it. But we are going to learn it throughout this program, and of course we are going to explain it with much more details. But this is the documents, just in case you need to go through it. Please feel free to do so.
So this document we can get it online? Or?
Yeah, I just shared the link with you guys in the chat. Yes, okay. I'm talking about the CRISP-DM document. It's available online.
Hey, Brother Mo, I got a quick question. This is Saeed Mohammed, by the way. So when you talk about this CRISP-DM methodology, right, is it applicable to the full life cycle of the model, like through the entire MDLC process, or is it just at the planning phase? If it is for the entire life cycle, how compatible is this with the agile methodology?
You could use this CRISP-DM within the agile methodology, but yes, CRISP-DM is used for the entire project.
All the way up to the deployment and
all the way,
training.
all the way up to the deployment, and all the way beyond the deployment, all the way up to monitoring the process, monitoring the performance of your automated system.
Okay. Okay. All right. Thank you.
You're welcome. So one things that that you need to be aware of, when you get hired as data scientist, one thing, very important things is the team sport. So data science is not a one-person job. So you have a problem here. I don't think there is a way you can do a good job by working on this project on your own. So we have to have a team, and within the team, within your team, you are gonna need people with 4 expertise. You could have 20 people in there. You could have 30. You could have 5. But in terms of their expertise, they have to be 4 expertise. So number 1, we are gonna need someone who knows the business better. It could be a business analyst. It could be domain expert. It could be a business expert. So someone who knows the business better. It could be your direct manager, but we need to have someone with a domain expertise. Why is that? So this person will always handle our questions, our concerns about any business problem. This person will guide us through the process of transforming the problem statement into quantifiable analytical statement. This person here will address any concern, any doubt, any unclear things about the problem itself. And of course, we are going to need a data engineer or data expert, someone who knows where the data is being stored, someone who can answer any doubt, any concern that we have on the data, someone who can guide us with the process of gathering the data. So this person has a knowledge, an experience of where the data has been, how the data has been used, how the data has been collected, how the data has been stored. He has all the answers in terms of the value of the variables, the data dictionary, etc. So he has all the answers that we have in terms of the data. And if you know that you will be deploying the model into production, you are going to need a developer. So I don't think deployment is your business. I really don't think. So it could be, a task assigned to you to deploy a model into production, especially if you have that type of expertise, and if you come from the developments and background, I think you could deploy a model. But in general, deployment handled by a third party or a different team. But the problem is, if you were not prepared for the deployment, then you might end up labeling your project as failed, because you might end up having a lot of problems explaining or translating what you have done to someone new, and you're expecting him or her to deploy it correctly into production. So we have to have a developer. His job is simply to understand how we conducted the machine learning project end to end. So once we come into the deployment phase, he's ready to do that without any problem. And of course, we are going to need you as a data scientist. We are going to need you as a data scientist, someone who can transform the data and the business problem into an insight, into a product that the management can use to make a better decision. And look into this. We have here 2 types of data scientists. We have citizen technical data scientists and citizen data scientists. So what? And by the way, this is I think their methodology, or their vision of the analytical team. So technical data scientist is someone who has an extensive experience in building models end to end. Someone who can take the data, can start a project for all the way from the beginning. From business problem through data requirement, through data preparation, modeling, testing, evaluation, optimization, and the deployment. That is technical data scientist, and it's a senior level of citizen data scientist. Citizen data scientist still would require the same experience, same expertise as a technical data scientist, but his main job is to monitor the model once implemented. So once the model is in place, is doing what's supposed to do live. So we need someone to make sure that the performance is as we expect. The model performance remains sustainable, remains as we expect. If there is a problem with the model, this person could shut down the model, modify it, fix it, and redeploy it. So the citizen data scientist is less knowledgeable, less experienced than technical data scientists. And here's the deal: if you invest in become a technical data scientist, there's always a chance you might end up, in the citizen data scientist, which is in the same discipline. And the more knowledgeable you become, the more experience you gain, then you move to technical data scientist. So this is a typical team sport. If you work hard first time, you are working for an organization, and you've been hired as a data scientist, you are working for an organization, and they really don't have an analytical team. This is your chance to approve yourself by simply establishing a team with for expertise, business expertise, data expertise, and data science expertise, and of course developer in case you need to deploy the model into production. Questions, concerns about the analytical team?
Brother Mo, I have a question.
Sure.
So if I understand it correctly, so the technical data scientist, he will go through the data models and come up with a data model, and he will hand that to the business data scientist. So, and the business data scientist will be like in charge of the support and maintenance of that data model. Is that what it is?
Yeah, you got part of it correct. So yeah, the technical data scientist is someone who conducts the analytics from the problem all the way to finding a solution. And once you design a solution, of course, that solution will be deployed into production with the help of developer. So we got developer to deploy a solution into production. So let's assume that we have a solution that approves, denies, credit card applications, and you really don't have a time to monitor how good the model is. Once the model is in production, so you will be assigned a different project, and we need someone who comes after you and will take a charge, on the model that is or the solution that have been implemented into production. So that is the business citizen data scientist, someone to simply someone who monitor the performance of the live implemented production model.
Yeah, got it.
And sometimes, if the model is not doing as expected, so you could, if you have the experience to fix it, you could, or otherwise you might need to call your technical data scientist to help. And once the model is fixed, we are gonna put it back, put it back and keep monitoring it. The data changes overnight, so we could build a model on a data with specific assumptions, but when the model implemented into production, the model will do very bad if the assumptions of the data does not match the assumptions of the data that we used to build a model. So the model will do very bad. So we need someone to keep monitoring the model. Otherwise, we will be probably doing a very we will be making a lot of bad decisions.
Hi, Mo. Can you hear me?
Yeah, please, Furkan. Yeah, I hear you. But please make sure Amin is clear. Then I'll give you a chance to ask your question. Amin, is it clear?
Yes, brother Mo. That's more clear now. Thanks.
Thank you. Okay, Furkan, what is your question, sir?
Yeah, thanks for confirming. Yeah, I was just trying to ask question through my headphone, and it was not happening. So I using computer microphone. So quick question is related to the developer role, right?
Right.
So as you mentioned, I would like to understand like this developer, is he going to develop anything like kind of a code, with the technical data scientist, or he's just deploying the code at the end of the,
So
like
yeah, that's a good question. It really depends on how the management decides to implement the model into production. So let's say this, technical data scientists build a pipeline. Yeah, let me move to a different. Are going to be building as a data scientist. Okay, so this is the pipeline. So this is you, data scientist. So you have the data. Comes in, and of course the data comes in, and the first thing you got to do with your data, probably fix categorical data. Okay, once the categorical data has been fixed, it's been transformed into numerical data, then you might need to normalize your data, or scale. Let's say scale. And finally, you are going to build a model. Let's say a regression. And we got an output. We got an output in here. Okay, this is the final. It's called pipeline, probably. I might be wrong. Yeah, it's called pipeline. So this is the pipe that you are going to learn. You are going to build after, of course, building from the beginning, from the beginning all the way to the end. So this is what you are going to give to developer, and developer will take this. And so these are going to be some codes, few lines using Python, you're using whatever programming language you are using. So the developer will take this piece of code and it will transform it into API, probably, or embedding code within. If let's say that your developer is using C++ or Java, you could embed the pipeline within the code and deploy it into production. So the developer might not be able to understand exactly what you are trying to achieve unless the developer was there from the beginning, unless you invited the developer from the early beginning. Otherwise, you are going to have a lot of problems trying to explain to him or to her what you guys have done. So again, the answer, developer could be someone who could design along the way. He could design a solution, another website or an application or a form. It could be anything. And once you're done with the pipeline, he's going to take the codes and embed it within the product he designed and implement that into production.
Makes sense.
Clear?
Yeah, it makes sense. Basically, so you are going to play a role basically to understand, analyze the problem, and mature the module with your expertise, and then you are going to engage with the developer, and maybe there will be some kind of documentation, maybe FSD, and then you explain and have a meeting with developer to understand, to make sure that he understood your things, basically how he's going to put those things into the existing application code so it can deploy in that application itself.
Later, yes. So sometimes the developer is a watcher, is simply watching you guys doing your things, and waiting for the end result or the end product that he will take and deploy into production. But he has to be with you from the beginning to make sure the transition goes smoothly. Otherwise, there's gonna be a block or a cutoff where once you're done with the development, you're trying to deploy it. There's going to be a miscommunication or misunderstanding between someone who built a model and someone who has no clue how the model was built, and they want to deploy into production. So we have to invite a developer if we know that the system we are trying to design will be implemented. Some of the models that you will be designing that don't require deployment. Simply the management that are looking for a score, are looking for insight. That's it. There's no deployment. Just give me the information that I can base my prediction, my decision upon. Okay.
Yep, and business citizen is basically playing a role for monitoring into the production your model, right?
That is
just to make sure.
That is part of it. Yes.
Just to make sure that it is working as expected and it is giving some kind of optimization. And is he playing like a kind of a production support, right? And then
yes.
Is he also
exactly.
providing some kind of metrics to the business that it was like this and now it is like this?
Yes, exactly.
Real time.
Yeah, that is exactly part of it. Yes.
Okay, thank you.
And business analyst is someone who can provide information, help you understand the problem. Data engineer or data expert, someone who can help you understand the data that you'll be using. Of course, that you'll be hired and with a company that that has years of historical data. You don't know how that data was collected. So we need someone who knows the data, who can help us get the data that we are looking for. You are not going to use 100% of all the data being generated throughout the history of the organization. We are going to use the specific data related to the problem we are trying to solve. And how do you know the specific data? We are going to need a data expert, someone who knows the data to help us with that.
So who is going to collect this data? Is that a data engineer? It could be in any form, right?
Yes.
JSON, X-file.
Yes. Yes, it could be in any form, and we will talk about that shortly. So who's going to win? Yeah, if you are very lucky, the data is there available in the tabular format, rows and columns.
If I have a question here.
Yeah, please, Hussein, give me 1 second, sir.
Yeah.
If you are not lucky, then you really need, and the top of learning data sets, you might need to learn how to extract the data on your own by simply learning some SQL. You don't have to be an expert. You are not going to be a developer. Simply learn how to fetch your data, merge tables, join tables, select the columns that you need, etc. But yes, the data engineers, they are responsible to provide you the data you need. But you are responsible to tell them what type of the data that you need. Okay, Hussein, Muhsin or Hussein, what is your question?
Yeah, Hussein, yeah. So you already kind of responded to the question. It was like a data scientist has to know some SQL. So because to match the type of the data with the model when building the pipeline, he needs at least to know some SQL just in case the environments are different.
Right.
So you said it doesn't have to know much SQL, but can you give an idea to the audience how much SQL he needs to know? Because
at least you need to know how to get your data. I mean, you will have probably said that now the management's granted you access to XYZ database. And in XYZ database, there are 50 tables.
What about the cleansing, the data cleansing?
That comes, that is not your, it comes, data cleansing, cleaning, preparation comes after. That is a process of the crisp DM.
Thank you.
So you could do it at the database end, but I don't think that is your responsibility. No, you could. No, that is a DBA responsibility, because you might end up doing something stupid to a database. So, and yes, that is not your responsibility. To cleanse your data at the database endpoint or database ending. Okay.
I have a question, please.
And Brother Mo, let's say if your data is coming from multiple sources like database, flat files, and JSON files, do you have to convert them into a single format, or does this model work with multiple sources?
We are going to talk about that in the future. Yeah, it's a future topic, so please hold on that. Let's focus on the topic of tonight. Otherwise, we are going to be wasting a lot of time going different directions. Yes, we'll talk about how to, and of course, the data might not always be in the format that you like, tabular format, CSV format, TSV, Excel. That is not the case. You can end up dealing with data from different sources, different shape, different structure. So you need to find a way to come up with one acceptable format, and we are going to learn that in the program. Okay, so that is the optimal data science.
One question. Yes. As a data scientist, so do we need to have some knowledge diversity?
Muhammad, your audio is not clean. Is not clear. Sorry.
How about now?
It's still not. Unfortunately, it's not clear, and there's a lot of background coming from your end.
Last later, then.
So you might need to type in your question, and Miriam, please go ahead and read, or Edward, please go ahead and read the questions for us.
Yeah, sure. We'll do it.
Yeah, sure. So an analytical team, as I said, you are going to need people with expertise, domain experts, someone who knows the domain, someone who knows the business, data expert, someone who knows the data, and you as data scientist, someone who can prepare the data, select tools, present. And sometimes you are going to need a manager. On the top of the expertise, we are going to need a manager. Someone, I really don't want, as a data scientist, I cannot waste my time and trying to figure out whom do I need to talk to, or trying to figure out how to get the data. So we have to have a manager, and it could be you, data scientist and the manager at the same time. So this manager is his responsibility: democratize the data, distribute the result, enforce learning. Means once you, especially if you are designing a solution to fix a problem on the fly. So once we determine the solution, we have to implement that solution, not in the production, within the organization. So we need someone to enforce that, and the manager comes into the play. And of course, you are going to need a developer if you know ahead of time that the solution you are about to design will be implemented into production. So this is a second mental picture that you need to remember and need to memorize to help you conduct a successful analytical project. So the first mental picture is learning the blocks. We need the data, we need the models, we need to learn the parameters, and we need to understand the objectives. This is the second mental picture, is the team, how I'm supposed to work on a project. And trust me, guys, even 3 years ago, I was hired to work on a project, and I was so excited, working for a big project, and I underestimated the time required to complete the project. I promised the manager, he's a friend of mine, that I would come up with a solution by the end of the day. And trust me, guys, it took me almost 3 weeks to figure out how to deal with the data. Because what happened is I jumped into, I worked on a project on my own. I have no clue what was the problem. No clue what is the problem. I don't have any idea what are the objectives. I don't have anyone to work with. I have a lot of questions on the data. I couldn't find help. I have to struggle with it. And guess what? It ended up wasting 3 weeks instead of 6 hours. So a team is very important. Otherwise, you'll be struggling, regardless of how experienced data scientist you are. So you are going to need a team to work with. At least if there is not going to be a team, at least I need to have some resources that I can go to in case I have a doubt, I have a concern about a problem, a business problem, about data, about a process, etc. Okay, so we can skip. So again, as data scientist, when you start working with the problem, understanding how the business operates at this point of time is a part of the game, is a game changer. Understanding the problem is a game changer. So number one, let's figure out how the business is doing the business at this point of time. So going back to the problem of our insurance, we know that we have an investigation team that investigates 30% of the entire claims, but still we are losing a lot of money. We are losing a lot of money. That is as is state. And now we want to determine, where do you want to be? What is the next state? The business wants to probably, let's say, wants to reduce the amount of, let's say that in this year, in 2020, we lost 1 million. 1 million in fraud. The business is very frustrated about it. Of course, 1 million is too much. And they hired us data scientists. We have something in place. We have an investigation team that investigates up to 30%, but still we lost 1 million. And the business will tell you, we want to reduce, realistically, we want to reduce this 1 million probably by 25% on the first 4 months, then another 25% in the second 4 months, then another 25% in the last 4 months. So the reality now. So this is the state that we want to be. And now you want to, so how do you measure? How do you know that you transition from state A to state B? It's simply by putting some identifying some measurement. So these are the business measurement called business measurement. So you have to have some measurement, otherwise you might not know how successful your product is. The measurement, it could be this percentage. The measurement, it could be the amount of money saved. The measurement, it could be it's quantifiable. They will tell you a number. The measurement, it could be the number of clients that we kept with the business. We were expecting a 10% churn, then we have now 1% churn. That is a success. That is a measurement. And you need, since you are working on our insurance problem, you need to determine the entity you are trying to analyze. The entity sometimes is called unit of analysis. Analysis is exactly what are you trying to analyze. So if you were to go back to our problem, when we are talking about the fraud, there's a lot you can analyze. You could analyze clients' behavior. So you need all the information about the clients, when they joined the company, when they purchased the premium, how much they paid, their age, their social security, their social, their demographics, and try to analyze this data and see if you can find anything strange that could trigger a fraud, a claim to be fraud legitimate. We could also analyze payments, credit card, cash, whatever method they used, auto payment, and find out, and of course with the payment you are going to have a payment ID, amount paid, the due date, how many times the client delayed in payment, how many times the payment were made in time, etc. So we are going to get a lot of information about the payment. We could also analyze the policies, policy ID, policy date, policy premium, etc. So a lot of information about the policies. And you could also analyze claims. And you could also analyze something else. That something else could be identified by the help of your business expert / business domain expert. So there's a lot of directions you can go, but you need to determine one of them, which direction. That is called the utility, or it's called the unit of analysis. So you need to specify, you need to narrow down the scope of your analytics. Otherwise, it is a lot of directions, a lot of effort, and you might not end up completing the project on time. So you need to identify the unit of analysis at the early stage of your project. That is called entity. Sorry, it's called entity or unit of analysis. And once you determine, let's say that we decided to analyze claims. Okay, and in claims we are gonna, so once you call in, if you are, let's say that you are our client and you called in to report an accident. Yeah, you called in to report an accident, and of course we are going to get all the information from you, your name, your demographics, your policy ID, and information about the accident. Who is involved, where, when, is there a police report, the injuries, the claims themselves, etc. So that is called the entity or unit of analysis. And now within unit of analysis, we need to determine what is exactly we are trying to investigate. And in our case, we are going to try to investigate if a claim is legitimate, so we can proceed with the payment and with the investigation, or is a fraud and we can stop it. So remember that as is we are losing, we already lost 1 million. Yeah, we already lost, we are losing 1 million every year, regardless of our our team, investigation team that investigate 30% of the entire population. So, and we want to move to a better state. We have some measurement to use to measure the transition, and we now will be for our data science we are going to use the claim, and now we are going to simply for the claim we want to investigate if the claim is legitimate or fraudulent. So once we design a system, yeah, please hold on, sir. Once we design a system that can determine the type of the claim on the fly, now once we design a system that can classify a claim as either legitimate or fraudulent, we are saving the business some money. So we are in the right direction. So let's say that Amin calls in to report an incident, and we find the system find out it is a fraudulent. So of course we are going to stop it right there. We are not going to hire anyone to go and investigate. We are not going to fund the claim. We are not going to pay anything. So we are reducing the 1 million that we lost every year by simply designing a system that could stop could identify and could classify a claim as a fraudulent. So we need to determine the entity or the what do you call it, the unit of analysis, and within that unit of analysis we need to determine what is exactly we are trying to predict or trying to analyze. And finally, we have to have some technical measurement. So first we identify the business measurement of how good the product that we are going to design is. But for our internal use, we are going to have some measurement to measure how the model is identifying a claim as legitimate or fraudulent. That is called evaluation matrix. It could be, excuse me, it could be accuracy, it could be RMSE, it could be IUC, F-score, accuracy. There's a lot of measurement that we could use. Yes, sir. And now someone has a question.
Brother Mo, identifying the identity could be from the TPA side, right? Not from the data engineer or the data scientist.
No,
so,
I think it's the whole team should be started
involved.
Involved. Yeah, the whole team. But the heavy work is on your shoulder. It is your responsibility. Yeah, it is your responsibility to guide them, and they are going to support with clearing any question you have, clearing any doubt you have in the data on the business. But identifying the entity, it should be your responsibility. But of course, you are going to need the help from the domain experts. The domain has been working in the auto insurance for 20 years. They have a lot of experience, that you don't have. You've just been hired for the last few days. So we need someone with 20 years of experience in that domain who can help us, identify exactly what we are trying to analyze. Okay, is a team sport. Is a team sport.
Brother Mo, one more question.
Sure.
So to define the exact entity, you will need the help of the team to pick which area you can start analyzing. So if you go into the route and let's say that that entity that you were like working on, it wasn't successful, it didn't bring
exactly. Yes. Thank you so much. Yeah, this is a very, very good question. So, and it happens. So all we have to do, if you look into the CRISP DM, I'll show you. We have a loop back. And I think here we go. So this is the CRISP DM. You could be you could have the same scenario. So you understood the business correctly, and that you picked let's say one entity that you want to investigate. You gathered the data, you went all the way, you prepare your data. When you got into the modeling, you are not getting anywhere. Always you need to go back and fix. So you went all the way to the modeling and you picked the claims, but you figured out, but this is not the right direction. It's always good to fix a problem at the early stage. So this, if you want to fix a problem here, it's less expensive. If you want to fix it all the way to the end, it's more expensive. Yes, always need to go back and fix anything that you think should be fixed before you proceed into evaluation and deployment. Good question, I mean. Other questions?
And Brother Mo, one more question. Can you go to the next slide? The one you had. Yeah, the last one. Yeah, this one. For the success metrics, like who's in charge of defining that success metrics? Is it the data analyst or is it's
the business?
The BA.
Yeah, BA. No, business. Your management. I don't know. Someone from is the owner of the project.
Oh, okay.
Domain.
Yeah, not domain is the owner. Someone who initiated the project. They could be the stakeholders.
Okay.
Okay, so if I hired you, if I have a problem I hired as data scientist. I am going to be the person who is going to provide you with the success. This is my criterion to determine if your project, if whatever you are going to design for me is successful. If you design something that will reduce, let's say that I have a business, and let's say that BBDS, so we are training data science, and next batch, probably only 5 students join the program. I hired those data scientists, and I'm going to tell you this program worth probably 50 students. So if you design a system that brings 50 students, that is a success. So I will provide you with the measurement. If you design a system that give me less than what I'm expecting, I would label your entire project as failed. So the business, the success will be provided by the business, by the project owner. It could be a stakeholder, it could be HR, it could be your direct manager, it could be finance, it could be an accounting management, it could be anyway, it could be the owner. It's the owner of the project. Okay, Amin?
Yes, thanks, Brother Mo.
Yeah, we can please. So, okay.
Brother Mo.
Yeah.
On this slide, it would be nice if we add the roles that you have shown before on the other slide, because some of these things are typically done by a business analyst, getting the requirements as is to be state. So it's a little confusing that, we have different roles in here. So it would be nice if who is the owner here, who is responsible to get all those things, that would be helpful.
Yeah, so this is your entire project, business understanding. You are going to need you and your architect or business analyst. Then, and when you get into data, we are going to need that. You are going to need you. We are going to DE, data expert, and developer. And when you are in data preparation, we are going to need you, data scientist, and of course we are going to need data analyst. In the trainer model, we are going to need only you, and in the deployment, we are going to need the developer. And update the model, we are going to need a data scientist. So, is this what you're looking for, brother?
Yeah, I think this slide, if it is part of your presentation, that would be great, because this is exactly, that will explain.
Yeah, so sounds
good.
Okay, good. Okay, so now talking about Aziz, this is the framework that you would end up using. And let's give an example, for the insurance problem that we have. So Aziz, we are losing money, probably, even though we have an investigation team that is an Aziz. Now, to be state is we want to determine the fraud, and we want to fight the fraud. This is simply without this. So of course you are going to have a detailed information on that. And the success is we are gonna reduce the amount of fraudulent by 50% for 6 months. This is simply an example. And the entity is the claim. The target is the fraud, is the claim, is a claim fraudulent or legitimate. And the accuracy or the matrix we are going to use is the accuracy. So this is a flow for this project. And as a matter of fact, there are some templates that you could use for your project, and you should be working on this as a team. Again, it's not a one-person job; it's a team sport. Yeah, this is a typical template that you need for your project. So you are going to need your name, and here the executive summary. This is the summary of the project, and of course you are going to need describe the project scope, data set description, project insight, project milestone, data. It's all about data. So yeah, project insight, milestone, data, etc. Now we are talking about the data first. You're talking about the milestones. You're talking about how do you compile your plan. So this is a lot. This is a template, and at the end you could have some references of how you conducted your project. Okay. So going back, to the trying to convert the business statement into a machine learning problem. So now, comparing this workflow with the business statement, there's a lot of this is more clear than what you started with, more clear than this business problem here. This is not clear. We don't know where to start. We don't know what direction. So that is called the business, problem framing. It's simply framing the problem or coming up with the frame that you could use to analyze your or conduct an analytical project end to end. So now let's go into CRISP DM details, and we are going to stop here, and we'll continue tomorrow. So this is our CRISP DM. So when you first hired, of course, you the first thing you gotta do as a team. Of course, you are gonna have a team, assuming now you have an optimal team with all the expertise required. The first thing you gotta do here is determine the objectives. What are the objectives of the business? What is the business that they are trying to do? It could be fighting a fraud by a certain percentage, reducing the fraud by a certain percentage, fighting or reducing churning rate by a certain percentage, cross-sell, upsell, generate more revenue by a certain percentage, etc. And once you determine the objectives, you need to frame the problem. And we just did a framing. A framing is simply transforming the problem, the problem statement into an analytical, quantifiable problem. And in our case, we decided to go through analyzing claims rather than, that is called framing, rather than analyzing clients, analyzing, let's say, policies, analyzing payment, analyzing something else. So now we have a good understanding of the objectives. That is a must. Then we need to frame, and framing by simply when you start framing your business problem, you need to start asking questions. You need to start asking questions. So you need to design a bank of questions, and questions could be descriptive, analytics questions like when, where, what, etc. Or you could design, you could come up with a list of descriptive analytics question. You could come up with a list of predictive analytics questions like what is the probability someone will respond, who is most likely to purchase an item, who is most likely to churn. That is called predictive analytics. You could ask questions in terms of why something is happening. That is called diagnostic analytics. And also you could ask questions in terms of what is the optimal method. That is called prescriptive analytics questions. What is the optimal method of doing a business? So you always, data science always start with a bank of questions. Bank of questions. And try to classify the questions in in the 4 type of analytics: descriptive questions, predictive questions, diagnostic questions, and prescriptive questions. And most likely you will be doing predictive and descriptive. Most likely you will be doing one of them, all of the combination, both of them. So you need to design, and that is the process of framing a problem. Framing a problem, you need to come up with a bank of questions. You always need to start with a bank of questions. And when you determine a direction, you need to assess its feasibility in terms of infrastructure, in terms of the data, etc. And of course, you need to know the business measurement. That is very important. And how would you measure the success of your product, of your system, once implemented into production, once you are done? Of course, you need to compare to be state with to as a state and see if the objectives, so the measurement to measure the objectives. We have to have an objectives and how to measure them. And so if you were to do predictive analytics, if you were to predict the likelihood or the probability of something to happen in the future, we have to have a target variable. We have to have a target variable. Yeah, we have to have a target variable. And target variable only applies for prediction analytics. Now, if you are not predicting, if you are doing only descriptive or diagnostic, I don't think you need a target variable. So target variable, if you know you are doing prediction, you have to identify the target variable. And you need to identify the analytic approach. What the approach you are trying to use. Are you trying to, this is the micro, exploration, discovery, or building a system that requires data, or building a system that is not dependent on data. In other words, you need to determine if you will be doing descriptive analytics, predictive analytics, diagnostic analytics, or prescriptive analytics. That is an important step in business understanding of your CRISP DM. So we are doing here, we are using CRISP DM to manage the project from the problem all the way to deployment of the solution for that problem into the production environment. So identify, also you need to identify the deployment plan. If you know that the objectives is to design a solution and deploy it into the production, you have to prepare from the early beginning by simply bringing a developer into the play, into the game. You need to develop, to bring someone from the development side, unless you have the expertise to deploy it on yourself. But I don't think that is your responsibility. So we have to plan for the deployment from the early beginning. Otherwise, once you are going to get here, there's going to be a bridge. There's going to be a gap between what you design and between how you are going to implement into production.
So what are the tools we are going to use for CRISP DM and for deployment on production?
What do you mean by what tools?
Like SAS.
Yeah, it could be. That is something that we are going to talk here. Yeah, it could be SAS, it could be R, it could be Python, it could be RapidMiner, it could be analytics, it could be simply Tableau, it could be Power BI for descriptive analytics, it could be BigML, it could be, there are so many tools, and in the program you are. And as I said, the first thing you gotta do as a data scientist or as an analyst is determine the objectives. Frame your problem. Start with getting, establishing or creating a bank of interesting questions. And you might not be able to do that without the help of your domain expertise and data expertise and the business expertise. we need to define the measurement, the business measurement, identify the target variable if you know that you'll be doing prediction, identify the analytical approach, identify the deployment plan if you know there's going to be a deployment, and of course we need to have a project plan. There is one difference, if you are project manager, you are probably familiar with how to conduct a project end to end. So the traditional projects, we have a start date, end date. We have some deliverables that you need to deliver across the project phases. In the analytical project, we still have start date, end date, but there is no way you can promise something to the management because we really don't know what to expect from the data. So we are going to have a project plan, but without a promise. We are going to promise that we are going to complete the project on time, but we cannot promise that we are going to give you XYZ patterns because we don't know what is exactly in the data. And finally, you need to identify the team and stakeholders. How important is that? It is very important to identify your stakeholders because they are the folks who can guide you and help you stay on a track. Otherwise, you might end up doing something unwanted. So, and with in the business understanding phase, you are going to be working heavily. We are going to rely heavily on our domain expert and a business expert. So all this is done with the help of the domain experts and the business expert. And finally, all as a team, we are going to design what we call analytical base table. After we spend times on understanding the business, we are going to come up with an analytical base table. And an analytical base table is simply what we call a pseudocode of what you need as far as the data is concerned. So let's assume that we agreed that we are going to do claims. Okay, so ABT is simply what is exactly the data that you are going to need for the claims. So of course we are going to need a target variable. We are going to need a data from claims. We are going to need the data from demographics data. We are going to need the finance data. We are going to need policy data. This data is what we call ABT. And we are going to take the ABT and now we are going to transform it into features, columns, and rows by the help of data expert. And we are going to stop here. And next time we are going to carry on. Tomorrow we are going to carry on. So let's stop here. I'm going to open the floor for everybody to see if you guys have any question, any concern, any doubts about anything.
So identifying the variable y, what does it mean? Y term in terms of business.
It's called y variable or target variable or an output or a label or an outcome.
Okay.
So it has.
So that y is also integrated with ABT, and then it will be given as handover to the next data expert.
Sure. So let's say that we agreed on going with and analyzing claim. Okay, that's an agreement. Now everybody in the team said, okay, let's do analyzing claims. No, we don't know if we are going to get anything out of it, but let's do it. So we got here claims. Okay, and we are going to borrow data. We are going to need, this is what we are going to need. We are going to need demographic data, right? We are going to need payment data, payments data. And we are going to need, this is historical data. This is from something that happens, something happens a long time ago, historical data. This has already happened. Okay, we are going to need payments data. We are going to need
policies.
Yeah, clients data. Yeah, we are going to need policies, data. We are going to need other data. Okay, and we are going to need claims data, all the previous claims. We are going to need them, and so since and we are going to need a target variable, target var, and this is our y variable. It's called y. So what is the target variable? So target variable, so when we combine all this data, we are going to have a table like this. Okay, are we all on the same page?
Yes, yeah.
Good. Okay, so let's assume we have 6 million.
All the above 5 tables are joined, and
yes,
it is in the tabular format.
Yes, yeah,
Am
we
I
have
right?
something like, yes, we got, let's say that we have 6 million records, 6 million claims in the historical data, and we got, let's say 300 columns. Okay, so this data is now useless at this point of time. So what we have to do is we need to go through all this historical data and determine if a past claim was fraudulent or legitimate. That is what target variable does. So we could do it manually. We are going to get, this is you. Let's say Amin had an incident long time ago. So we have his age, his social security number, marital status, income, this and this, and we want we need to go and invest in that past incident to determine if it was fraudulent or legitimate. Let's say it was fraudulent, legitimate, 0. Then we got here Mo got a lot of information, and his claim was actually we find out later is fraudulent. Then other one 0, 0, 1, 0, 0, etc. This is our target variable. And target variable is not in a database. It's something that we need to determine. We could do it systematically using some rules, or you could go through one at a time to determine if it was legitimate and or fraudulent. I'm talking about all the 6 million accident that we handled in the past. So this is our y variable. We are gonna need, if we were to use prediction, we are gonna need this animal in our data. Clear?
Yes, but surprisingly, we are trying to get the information in y variable, whether it is legitimate or fraudulent. We are going to get that only based on from the historical data. Yeah. And obviously, the historical data will be termed as legitimate, right? As historical data already was claimed, and the claimant was got his amount.
Yes,
but so obviously for all of them it will show as legitimate, not as fraud.
No, some of those claims could be fraud. Yeah, you could call us. You called us. 6 months ago. You lied, and we process your you process the claim. Mm-hmm. You got the money, but after 6 months, we find out you lied to us. There is nothing we can do, but we are going to label your case as a 1. Mm-hmm. Okay, so we need to go through all these 6 million or 500 or even 10 claims and determine if they were actually fraudulent or legitimate. You are going to find at least 2 to 3% of the 6 million that were actually fraudulent, and that is what we need to get from the historical data. And once we have historical data, we are going to use a model to determine the mathematical relationship between all these elements and the target variable. So we are going to find what we call a pattern or relationship, and this is what we are going to use for tomorrow. If tomorrow you called me to report an incident, we are going to apply these patterns and relationship on your information provided and we are going to determine if you are a 0 or a 1. If it's a 1, then we are going to stop it. If it's 0, we are going to let it go. Clear?
Hey, Mo.
Yeah, please hold
Hi,
on.
Mo.
Everybody, please hold on. Let's make sure that her brother who asked question is clear with this question.
Yes, yeah. I'm clear with this.
Thank you, sir. So next question.
Yeah, hi, Mo. Can I ask a question?
Yes,
This is Hari.
Yes, Hari.
Yeah, so I want to ask a question on this, the bigger table you made on the left side. You're saying that, so does the company do auditing like every quarter or something? I mean, how do they find out, okay, based on, I mean, what evidence do they have in future to find, oh, this guy, person X or person Z has made a false claim? And how do they, I mean, convert the 0 to 1? Because when they processed, obviously that time it was legitimate under their rules and regulations.
Yes.
Do they change the rules? I mean, how do they turn 0 to 1?
Yeah, so a good question. Yes, you have to do some auditing. You know, sometimes you approve some an application that was not supposed to be approved. It looks like a missed the requirement, but there is something in there that makes it tricky, and you approved it anyway. So if you do an auditing, you are going to filter out those who are actually were supposed to be approved and those who are approved wrongly. So one way to come up with to label your historical data is by conducting a thoroughly auditing of all the previous cases. You could hire someone to do it. You could put a system, logic behind it. Every amount exceeds if the claimant amount exceeds this number, we should investigate it further. You could do a lot of things to classify, to label. So we have historical data. We need to label them. We need to label every case of the historical data as either they were approved correctly or they were approved wrongly. So those who are approved correctly, we give them a 0, or we give them yes or no, or simply L, legitimate. Those who were approved wrongly, we are giving them F, LF, LF. That is called labeling. So we need to label the historical data by applying some type of kind of auditing. How do you do the auditing is totally up to you. The auditing could already been done, on the weekly basis, after the fact, after they approved your claim and you went with the money, but still the business remembered that it was fraudulent. Probably there's nothing they can do to get their money back, but we learned from it. Okay.
Thanks.
You're welcome. Yeah, 2 more minutes, and I need to jump into the other class.
May I ask a question?
Yes, ma'am.
Will you actually teach coding here as well, like maybe the basics or the advanced?
Yes, we are. Yeah, we are gonna. Once we get into the data, we are gonna learn how to use Python to process data. So in the first phase that we are talking about now, no coding is required. The coding starts in the data understanding. We are going to start reading the data. Then we are going to start manipulating or wrangling the data, applying some ADA, data visualization, analytics, and more coding on data preparation, more coding on modeling.
Got it. I mean, is practical application going to be a part of this course?
We are going to use Python.
Okay, great. Thank you.
And of course, there are other applications don't require any coding. So I'm gonna require any in a programming. It's free. You sign in. Yeah, you sign into Azure email and you start building your model. Very simple. It does not require any programming, but of course, you want to be a data scientist. We want to see some coding. So after you understand the problem, you get your data. It's a new. I'm going to start a new here. I'm going to start this, fraudulent, open up this case. So the data already is there, and we'll learn the Azure ML. We'll learn the Azure ML in the program.
Oh, so do we import data from an Excel sheet here?
Yeah, you go to data. You go to new, data set, import from the local. Then you import the data. So yes.
Okay, and does it allow scraping as well? Like we can directly scrape data from a website?
Yes, you can read the data from different sources.
Okay, by the way, I'm good with coding too, but I was expecting to learn more here in this program as well. But this is a great tool. I'll definitely look into it. Thank you so much.
Yeah, the first phase, being a good coder is not going to make you a data scientist. So you have to understand the big picture. You could be one of the best, Python programmer, but it's not going to take you anywhere if you don't understand how to conduct a project end to end. Yeah, coding is a part of the game, and it could be the game changer. But if you don't know, if you don't have a good understanding of the problem, you don't have a good understanding of target variable and ABT, your coding is not going to help me. If you don't have a good understanding of the data, your coding is not going to help me. So that is why you start step by step. Yeah, you might feel like the first phase is simply blah blah blah, but that is blah 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 is going to help you to conduct a great analytical project.
Got it. No, it's useful indeed. I was just asking. Thank you so much.
You are welcome, ma'am. You are welcome. Okay, folks, that's it for today. I'll talk to you tomorrow. Until then, you guys have a great evening. Assalamu alaikum wa rahmatullah. Bye, everybody.
Bye bye.
Assalam.
Thank you, sir. Jazakallah khairan.
You're welcome.
Thank you.
Jazakallah khairan.
Thank you, Mr. Safe.